Now for the fun stuff. The first thing I'm going to do is create a variable that is called old position and set it to the current position, which appears to be counterintuitive, but it's going to make a lot of sense in a few minutes because the current position now is my future old position on the next frame. So let's disconnect the line trace just for a second and plug this in. If I just preview this, I can draw a debug line. Cool. Put this here. And let's take the current position and the old position as the start and the end of the line. And the line color, let's put it red. Okay. The thickness, let's put it to 10. And if I compile, save, don't know if you can see, but I can get a velocity out of the old position and the new position subtracted from each other. So this is how I'm gonna get the this blue arrow here. If I just subtract one from another, if I subtract the current position and the old position, then this will be a velocity. Perfect. So this was just for previewing. We don't need this anymore. We can just unplug it. Replug the draw line for object. Cool. We're not gonna need the make rotation from X and Z. What we're gonna do is take the impact normal and make rotation from X and Z. We can plug that into rotation. And what we want to do is take this vector and rotate it 90 degrees on that for it to match this one, right? So we're gonna need a node that's called rotate around axis. Plug that into the Z. We can plug that in here, and let's put minus 90 degrees here. And so we're gonna need another node that's called just cross product. Cool. Let's plug that into the axis. Let's put the normal here, and we're gonna need this one but normalized. All right, cool. So now I should get the exact axis that I need. So if we look here, this is the impact normal. This one is this, and this one will be the cross product. So if I decide to plug two axes into a cross product, it's gonna give me the other axis. I don't know if that makes sense. So I'm gonna be taking this one, rotating it 90 degrees on that axis, so it's gonna be matching the cyan arrow. So if I plugged everything correctly, I should press play. And it's not quite working. Let's see why. Okay, I just figured out why it's doing that. It's because your set all position needs to go at the very end. So you just unplug it, placing it at the end, like this. Compile, save, and voila. Now you get an arrow that is oriented flat on the surface, but like oriented towards the direction of the camera. Pretty cool. So now what I'm gonna do is a little thing that checks if the velocity is below a number, and if it is, then it's gonna give a random vector instead of the velocity. So I'm gonna create a node that's called select vector. this is gonna go into B. This is gonna go here. Cool. So now from this, I'm gonna create a vector length. So I'm gonna check the speed, and if it's less than 1, I'm gonna plug that into the chooser here. Cool. If it's more than 1, then keep this, and if it's less than 1, then I want a random one. So I'm gonna choose a random float, copy paste this 3 times, because if we take the same value for the x, y, and z, it's gonna be like a weird constant axis. It's not gonna give a true random. So you create a make vector with a random for each, like this. Oh, I'm gonna make sure that the values are between -1 and 1 instead of 0 and 1. So I'm gonna, to do that, you multiply by 2 and you subtract 1. Alright, so the only thing that's doing is giving us a random vector in the case that it's not going fast enough. So if it's fast enough, it's oriented. If it's not, it's random. See? It's pretty cool. And if it's too far, then it doesn't emit. Cool. Before moving on to the decals, I'm gonna do a quick function here that will allow me to emit once every number of seconds instead of every single frame. So what I'm gonna do first is create 2 float variables, and I'm gonna be naming one time accumulator as a float, and another one it's gonna be called I don't know, every n seconds. Cool. So if I compile, I'm gonna put this one already to 0.05. Cool. So I can already take the time accumulator and set it as well. I can get a node called get world delta seconds, add those 2 together and set it like this. So this is gonna accumulate time every tick, and after I'm gonna check if it's reached the number of seconds between every emit I want, and if it does, then emit. If not, then continue. So I'm gonna take the time accumulator again, this one as well. Gonna take a greater than, plug them in like that, create a branch out of this. If it's true, then I'm gonna set the time accumulator to 0 again every time. Cool. So this should mean that I will do everything else in the branch every 0.05 second. So it will prevent having too much arrows emitting back to back. So I can already see it working, but let's increase the value to like 0.5 so that every 0.5 second it will emit. Now that's clearly not enough, but you can kind of see where I'm going with this. Back into Niagara, what you can do is just copy paste the arrow mesh, call it decal, and I'm gonna delete the mesh renderer, put a decal renderer instead, and it's complaining that it's a GPU emitter, so let's put it back to CPU. Cool. Now in this tutorial I'm not going over how to create a decal material, because it would go a lot over the time that I gave myself. So I prepared like a decal material that I can just use. So if you want to see what it looks like, you can just drag and drop it in the world, and so you can see the decal here. So do I have something else to change? No, everything is fine. Particle spawn. I'm gonna create in particle update decal attributes, which is I believe new in Unreal 5.5, 5.6. I'm using 5.6.0, so if it doesn't exist, then it's pretty easy to set attributes one by one with the set new or existing parameter directly. But it's cool that they included that one in Unreal 5.6. So let's go size, apply, direct set, yes, and I'm gonna break this. The x-axis will be like the thickness of the decal. It doesn't need to be very big, so let's put it to 20 so it doesn't stretch on like perpendicular surfaces. The y-axis will be 200, and the z I like to put not random, but make custom float from boolean. So the boolean will be random. Just put a random bool, and if it's true, let's put minus 200. If it's false, minus 200. If it's true, plus 200. So every time a decal spawns, it's gonna be plus 200 or minus 200. Nothing else. The orientation, I'm gonna apply system, and I'm gonna put a direct normalized angle of 0.25. So this is gonna just make sure that the decal is spawning in like a 90-degree from the default, so it's gonna match the arrows that we had previously. The fade I'm gonna apply, put a curve in there. Let's put it to auto and make it fade like this with normalized age. Yep, that's pretty good. So if I press play, then I have some decals happening that are oriented like the arrow was. That's pretty cool. Now we can get fancy with changing the color and shape of the decal. So right now I'm using a texture like this that chooses randomly between these three decals. And in the material I'm using the decal color to vary the color and also the which decal it is on the flipbook. So if I just go into initialize particle and put a random in the color, then what's gonna happen is it's gonna take a different color and a different shape of decal every time. And that's pretty much it. Let's activate the arrow back. So that's pretty much it. I hope you guys enjoyed the tutorial, and since this is my first video, I would like some constructive criticism if you have any. Yeah, I hope this will be helpful. Thank you guys. Until the next one.